Hello, welcome to the machine learning at home. Today I will speak about kmeans, very typical method of clusterization. However, not a typical k-means at all. It's called spherical k-means. So normal k-means try to make clusters as tight as possible. It will minimize the Euclidean, the straight distance between elements of the cluster. Whereas spherical kmeans work with the idea of like constellations of stars. So it tries to minimize the angle between these elements or stars. So this is a very different approach and will return different clusters. In some ways, these typical k-means might be better than spherical. Sometimes spherical might be better than typical. So you need to try both if you want to see how well you achieve the best clusterization. So let us start. First of all, we need to load library as kmeans. So everything loaded without problems, because in my case it's already installed. So you might want to install it with install.packages in plural and as kmeans in quotes, and then run library as kmeans like just I did. And we will work very simple way, just default way without any options. That's probably one of the best ways to check how these things is working. So first of all, we'll take some data. In data, I typically take the iris data because I know it very well. It's also very good for me because it's flowers. So, and we'll name the resulted object iris as key. And I will run the command as kmeans without any options. And the only difference from typical k-means, this command wants metrics, not a data frame. So we should convert as metrics. We'll convert data frame of irises into metrics. Iris. And we need to take out character number 5 as usual because it contains names of species. And also we want to specify the number of clusters which we want to produce, right? So in that case it will be 3 clusters, because we know there are 3 species anyway. And we can run it. Well, it's slightly slower than typical k-means. And now how to do anything else, how to compare. For that reason, you will need my package, library, ship-enough. And my package contains very nice variant of, well, misclassification command, confusion matrix, which allows you to work with clusters even if their names are not exactly same. So we should run misclass. Misclass of what? We just made our clusterization and object name is iris.asKey. And within that object there is an object cluster. So exactly like in typical k-means. And then we will compare it, like try to see the confusion, disagreement with species names iris, which are contained in character number 5. And very important is to specify best equal to true, because this is a case when cluster numbers names are different. Character number 5 from iris contains species names. A cluster part of iris as key contains just numbers. So we want this option. And that's it. And whoa! This is very interesting. You see that misclassification error is extremely low. Actually, almost the first time I see such a low misclassification error. Let us compare it with a typical k-means to see how it works. So typical k-means work very simple way. So it will be k-means without s, and then we use like km, for example, as an object name. We don't need conversion to metrics. Otherwise, everything will be exactly the same. A bit faster, of course. And then we'll use some misclass command. Just change name of object KM cluster, and I think that's it. Okay. Oh, that's really bad, and sometimes it depends on random factors. For example, if we can continue to run kmeans, we might achieve some smaller misclassification rate, but still much bigger than in spherical kmeans. Let us do it again. Same 10.7. So you see that spherical kmeans will give beautiful result for the iris data. So I would regard it as a very reliable method, at least in some cases. So you should try spherical kmeans with approach to find kind of constellations in your data. So this is it for today. Thank you very much.